Okay, so we are going to start chapter 2 today. And after we finish chapter 2, you should try chapter 2 homework. Okay, so chapter 2 is about motion along a straight line. And we are going to learn different variables that describe the motion, like speed, velocity, position, and acceleration, and of course time. Okay. Um, so motion along a straight line, first you have to understand what is the definition of motion. So in physics, motion is the change of an object position or orientation. So you can like move the object from position 1 to position 2, then that's in motion. And also you can like rotate an object, that's changing orientation. So it's either change position or orientation. So sometimes the position didn't change, but the orientation changes is also in motion. So chapter 2 is the easiest case when the motion is along a straight line. Okay, so we can use a reference frame and this object will move along the line. Okay, so this is what we are going to learn today. And we have some learning objectives. So basically that's what it covers in each section. And we are just going to go over those sections. So here, kinematics is the classification and a comparison of motions. So every equation deals with motion is included in kinematics, and future chapter we are going to learn dynamics. That is the reason behind the motion. So kinematics deals with the equation that describes the motion. So in this chapter we are going to learn our motion and we have restrictions. So we are only going to consider motion along a straight line, and we only discuss the motion itself, so not the reason behind it, not the force that caused it. And we only consider the moving object to be a particle. So we are not going to, so if you have a pen, like if you rotate it, it may become like orientation may becomes like this, so rotate it. But if we are going to consider this pen a particle, like this particle, so particle do not have orientation. Particle is a mathematical point. So we are not going to consider the rotation, only the one-dimensional motion. So here we have definition of particle. Particle is a point-like object, such as an electron. So you are not going to consider the shape. It's just a point. Okay, so an object that moves such that each part travels in the same direction at the same rate. So no rotation or stretching. The shape of the object will not change, and also the orientation is not changing, and that's a particle. Okay, so this is the restrictions on the motion we are going to study in this chapter, and they are very easy. Okay, this is the easiest case, so we are going to start with a very easy motion first. So here we have to learn a few physical quantity in order to describe our motion. The first thing we are going to learn is what is position. Okay. So position is measured to a reference point. So in physics, we use the reference frame as what we did in math. We are going to use x-axis and then y-axis. Okay. And we have an origin. So like here, the origin or 0 point of an axis. So this is the origin. And we have position. So if the object, so how to measure the position? If we chose the x-axis to be our direction of motion, then we can put our object here. So this is our particle, okay? So the position of this particle, we are going to use x coordinate to describe it. So this is x, okay? X. And usually in a coordinate system, we are going to label this like x, okay? And x coordinates is the position of the object. And the position has a sign. Positive direction is the motion. is the direction of increasing numbers. So you are going to see usually to the right, by convention, okay, to the right is positive. This direction to the right is positive. And of course, we have negative direction is the opposite of negative. Negative is the opposite of positive. So if you are here, then our position, so if the object is here, then our position of the object is positive 2. And if the object is here, the position of the object then will be negative 2. Okay, so very easy to define position. And then since we define position, we are going to run another thing to describe the motion is a change in position is called a displacement. Okay, so understand what is displacement. Displacement is the change in position. So suppose we have an object move from 2 to negative 2. So it's like this. How to calculate the displacement is we are going to use final position minus the initial position. And final position here is negative 2, initial position is 2, so we should use negative 2 minus 2. And usually we write it like this, x final minus x initial, and we use delta x represent displacement. So delta x will be equal to final position minus initial position, which is negative 4 meters. So this is our displacement. And you can see here, delta x will be equal to x2 minus x1. And usually I write it as x final minus x initial. It's all different representations. Okay, it's the same. 2 is final and 1 is initial, and here final is sub f is final and sub I is initial. It's the same thing. And we have different examples here. It's if we have a particle move from 5 to 12, how to calculate displacement? You have initial is 5, you have final is 12, so the displacement is 7. And here we have initial is 5, final is 1, then our displacement should be 1 minus 5. That's why we have this negative 4 meters. And usually our unit for displacement, since it's a measurement of a length, so that's why it's in meters. But we also have this. If we have an object go from 5, so 5 is here, and go to 200, and then go back to 5, like this, the displacement by definition is final position. So final position is 5 minus initial position is also 5. So 5 minus 5 equals to 0 meters, but the actual distance covered is irrelevant. I also want to talk a little bit about the concept distance. So we know displacement delta x will be equal to x final minus x initial. I write an arrow on top because displacement is a vector. It means it has direction, which is it has it has direction. So it has direction. So it has positive or negative sign. Okay, so this arrow represents this quantity has direction. It could be positive or negative. I should write it this way. Okay, positive or negative. But distance is a little bit different from this displacement. Distance is the length of the whole path. Okay, the length of the whole path. So if the object go from 5 and then go to 200 and then he decides to roll back to 5 meter. We know the displacement is 5 minus 5, which is 0. But distance is the length of the whole path. If the path is what I drew, like this here, do you guys know what is the distance? So go from here and then go back to 5 like this. Can you calculate the distance? By definition, okay, distance is the length of the whole path. How to find the distance? If you know, you can type your answer in the chat so I can see it. Very good, very good. So you should use, so see here, for the distance, we have going forward and we have going backward. So we have to add this, the length of these two segments. So it's the length 1 plus length 2, and it's 195 plus 195. You know why it's 195, right? 200 minus 5 is 195. So it's 390 meter. Very good, Justin. It's right, 390 meter. So now you can see the difference between displacement and also distance. Displacement, just the final position minus initial position, and distance, you have to consider all the passes. It is the length of the whole path. You have to consider all the segment that is actually happened in the path. Okay, so if you have like zigzag path, then you have to calculate this part, and then this part, and then this part, and this part. So distance usually is very difficult to calculate. So this is that. Okay, so here we have our displacement. You can see we have positive or negative sign, like from 5 to 12, it's positive 7, from 5 to 1 instead it's negative 4. So it has positive direction or negative direction because the object can either go this way or go the other way, right? Here, go this way, it's positive. And then if the object go this way, it's negative. So that's why our displacement is a vector quantity. A vector quantity means, so in physics, we have scalar quantity and we also have vector quantity. Vector quantity means it has magnitude. It also has direction, okay? Magnitude and direction. So magnitude, you have to give me a number and give me a unit. Okay, and direction. So it's not definitely this, but it's number multiplied by unit. And then direction, it could be positive or negative for one-dimensional motion, okay? So direction along a single axis given by positive or negative magnitude is the length or distance. In this case, the unit will be meters or feet, but the standard unit for length is meters, okay? So ignoring the sign, we get its magnitude. So it has magnitude and direction. So if you have, this is negative 4, displacement is negative 4, then the magnitude is 4 meters. Okay, so magnitude is what we call absolute value. Okay. So here we are going to have an example. So we have 3 pairs of initial and final positions, respectively, along an x-axis. So which pair gives me a negative displacement? A, B, C. Okay, I want you to tell me what is so this is the initial position and this is the final position. I want you to calculate the displacement for ABC one by one, and you tell me the answer, okay? So what is the displacement for A, and what is the displacement for B, and what is the displacement for C? So A is going from -3 to 5, B is going from -3 to -7, and C is from 7 to -3. So tell me what are the displacements? And if you know the answer, you can also type it in chat so I can see. Very good. Got 8 meters. So how to get 8, -4, -10. Very good. Okay, so 8, -4, and then -10 meters. Very good. Okay, so use final minus initial. This is 5 minus -3, and then for B and C, we have the answer here. So for now, you should understand how to calculate the displacement and then what is the difference between distance and displacement. You have something like this on your homework, so make sure you understand the calculation. It's very simple. And we have more equations goes along with this in the next section because we are going to run a new quantity. It's what we call the average velocity. So what is average velocity? Average velocity is the ratio of, because velocity is the measurement of how fast an object is moving. So how fast the displacement changes. So that's why we need delta x, and we also need the delta x happens during delta t. We also need the time for the motion. So that's why we have average velocity will be equal to the displacement divided by the time interval in which the displacement occurred. So here T2 minus T1. So T2 is usually our final time, T1 is initial time. So if the object move from like 2:49 p.m. to 3 p.m. So that's 11 minutes. You can calculate the time. And then this on the top, the numerator will be our displacement. Okay, so this is average velocity, and we also have average velocity have unit, which is meters per second. Okay, meters per second. So average velocity will be displacement divided by time. Okay, meter second. It should be displacement, but displacement is also have unit meter. So meter divided by time. Okay, so here we are going to use graph to relate the relation, actually to see the relation between the displacement and our velocity. So here on a graph of x versus t, the average velocity is the slope of the straight line that connects 2 points. So you guys know what is the definition of slope. So here, if I draw a picture x as a function of time, so usually our displacement, if our velocity is positive, then our displacement will increase with time. So you may get a graph look like this, okay? And if you want to calculate the average velocity, what you do is you are going to use the rise. So the rise here over run here. So this is your delta x, and this is the delta t. So delta x is the rise during this amount of time, delta t. And our average velocity, you can say we average will be equal to rise over run, which is delta t, delta x over delta t. So this is also the definition of slope. Okay, slope by definition is the rise over run. This is from calculus 1. Okay, you should know this concept already before you come to physics 1. Okay, if you don't know this, you should know this. If you don't know this, then you didn't meet the math prerequisite. Okay, so you should know this. And here, average velocity is also a vector quantity. Positive slope means positive average velocity, and negative slope means negative average velocity. So we have this kind of picture. X increases with time. We can also have something look like this. Okay, so if our velocity is negative, you can see this object is moving along the negative x-axis. So t increases and it moves down further, and you are going to get a negative slope. So that means the object moves along negative x direction. So here, what I want to show you is this picture and how to, what is definition of slope, and actually slope is the average velocity, okay? So from these 2 points. And we also have average speed. Average speed is the total distance divided by the travel time. So here it's S average. So S, usually V represents velocity, okay? And then you are going to see the S here. S here represents the speed. So speed equals to total distance divided by travel time. And because our distance by definition is the length of the whole path, the length is not negative. So average speed is always positive and has no direction. Velocity has direction, okay? And position, and also our position, the displacement delta x and v has direction, but our speed and also distance is no direction. Okay, so if we have a particle moves from 3 to -3 meters in 2 seconds, so from we can do from 3, which is here, this is 0, and this should be -3, okay? And our displacement should be -3 -3, because this is the final, and this is the initial. So final minus initial, -3 minus 3, you are going to get -6, and your velocity will be equal to -6 divided by 3. So you are going to get -2 meters per second. But, wait, 2 seconds, sorry, 2 seconds. So you are going to get -3 meters per second, but your speed here, speed is the length of the path, which is length of the path is positive. So you should use positive value divided by 2. You are going to get 3 meters per second. So remember, average speed and distance have no direction. So there's no negative sign, but our displacement and velocity have direction. Okay, so see the difference here. And also, so after that, we know what is position, displacement, and average velocity. We also need to know something called instantaneous velocity. So it's not average, but it's a velocity at a given time. So at a given moment. So instantaneous velocity and speed. We can take a look at this definition here. So what is instantaneous velocity? Instantaneous velocity, or just the velocity, it's the velocity at a single moment in time. So what is that? If you are driving a car and you can read the number on the speedometer on the car, so that number is the instantaneous velocity, okay? It should be the absolute value of your instantaneous velocity. That is because that velocity will change over time. So if you hit the brakes, then the reading will change. So the moment you are doing the reading, that is your instantaneous velocity, okay? So how do we get instantaneous velocity? Is obtained from average velocity by shrinking delta t. So remember, what is your average? So this is the, remember our V average will be equal to delta x divided by delta t, right? So changing position over changing time. So if this is the average during delta t, but if we put delta t goes to 0, so shrink it, it will give you the velocity at a given moment. So we do it like this. It's the limit of delta x over delta t as delta t goes to 0. So remember, it's a limit, okay? So as delta t goes to 0, what is your velocity? And that is your instantaneous velocity. And the slope of the position time curve for a particle at an instant is the velocity. So if you have this x as a function of time curve, so it may look like this. You are going to calculate the slope at this given point. The slope at a certain point is the tangent line along the point. Okay, so the velocity, the slope here is your instantaneous velocity at this time t0. Okay. And it's also a vector quantity because your displacement is a vector, then your velocity is also a vector. And the sign of the velocity represents its direction. So as delta t goes to 0, you are going to see velocity will be equal to dx over dt. Have you ever seen this before? This should be in your calculus 1, okay, derivative. So if you have x as a function of time, you take, so if you have x, what is x? X is a position. If you have position as a function of time, you take first the derivative, you are going to get your velocity. Okay, so be very careful of that. Okay. And the speed is the magnitude of instantaneous velocity. Okay, so if you get a negative value, then you take the absolute value, then you are going to get your speed. So see here, I'm going to write it this way, where V equals to delta x over delta t, okay? And you can write it as this, xt, x as a function of t, and you do first the derivative, okay? So here, this is the explanation of this. A velocity of 5 meters per second and negative 5 meters per second both have associated speed of 5. So for speed, it's just losing the negative sign because speed cannot be negative. Okay, now we have a checkpoint here. This is very important because you have a homework problem that looks like this, ask you to calculate the velocities, okay? So the following equations, if the position xt of a particle in 4 situations, in each equation, x is meters and t is in seconds. So first one here, it's x equals to 3t minus 2. And the second one is x equals to negative 4t squared minus 2. And the 3 is x equals to 2 over t squared, and the 4 is x equals to negative 2. So the problem asks you, A, in which situation is the velocity of the particle constant, and B, in which situation v is negative. Okay, v is negative. So how to do this problem? Remember our definition is v will be equal to dx over dt, which means the first derivative of this guy, you can get your velocity. So I can do one with you. If you take derivative x prime t, you are going to get, so 3t, you are going to get a 3, and then negative 2, you are going to get 0. So this is the first one. And the second one, how to do derivative, dx over dt. You can write it this way, okay? This way, v equals to dx over dt, taking derivative. And you are going to get negative 8t, and then plus 0, negative 2, take derivative, you are going to get you are going to get 0. And then number 3, you can write it this, you can write it like this. So 2 over t squared is 2 to the power of t, 2 times t to the power of negative 2. Okay. And then, yeah, I want you to try 3 and 4 to see if you remember how to calculate derivative. Okay. So try this by yourself. And you can also tell me the answer in chat. If you don't know how to type t to the power of negative 2 in your box, you can type it like this, t hat negative 2. Okay, so this is t to the power of negative 2. So see if you can get the right answer. Okay, let me see. Very good, very good. And then, yes, very good. So number 3 is v equals to negative 4 t to the power of negative 3. So it's negative 4 over t cubed. And the number 4 is 0. Okay, so taking derivative negative 4 t to the power of negative 3. So very good. Do you guys remember how to calculate derivatives? Because later on you are also going to learn about acceleration, which is the double derivative of x. First derivative you get a velocity. Second derivative you are going to get acceleration. Okay. So this is that. And which situation is the particle has constant velocity? So say here 3 and 0, they are constant, and which is in negative x direction. So negative 8t, this negative x direction, and negative 4 over t cubed is also negative direction. So once you get the derivatives, and you are good. And also, for example, I think in your homework problem, it also asks you to calculate the velocity at t equals to 1 second. Oh, if I give you the time, how to calculate velocity if this is given to you. So at t equals to 1, let me use number 2 as an example, okay? So at t equals to 1, for case 2, our position, you put 1 here, is negative 6, right? Negative 4 minus 2. I I skipped a step. It's -4, 1 square minus 2, so it's -6 meters. But our velocity, how to do it? You should use this guy here and put t equals to 1 there. So you are going to get -8 multiplied by 1. So you are going to get -8 meters per second. So if the time instant is given to you, then you should be able to calculate what is the x and what is the v if the position as the function of time is given to you. And later on, you can calculate your acceleration as well. Okay. So here, this is also a graph. We can also take a look at this. The graph shows the position and the velocity of an elevator cab over time. So you have this graph here. The slope of xt and also the velocity v is, what is it? Oh, see here, this is the position as a function of time. And you can use the position as a function of time to get the velocity of the function of time. So how to do that? You are just going to take a derivative here and then derivative here. So if you get a horizontal line here, that means your velocity is 0. So this is the same as segment A and then segment, so this segment A and the segment D here. So you can see this little guy here. And the B, from B to C is a straight line, so it's a constant velocity you can see here. And from 1 second to 3 seconds, this is a curve. So a curve, so see here, a curve usually tells you the velocity is increasing. So you can see this is a curve. So that's why velocity is increasing, and we have velocity go from 1 to 4 meters per second. So velocity is increasing during this segment. And also go from here to here, the velocity is decreasing from here to here. If you want to calculate this line here, you have to take a look at this curve, okay, this curve. And use the rise over, actually. You cannot just take this curve. You have to know the position. You have to know xt in order to draw this graph, okay? You cannot use rise over run for this because the velocity, the slope is changing for this curve. We have to have xt in order to draw it. But this picture goes along with this graph, okay? So if you have a curve, you have changing velocity. And if you have a straight line, you have constant velocity. And if your velocity is 0, then your position is not changing. So if your horizontal position, then the velocity is 0. And if you have a curve look like this, then your velocity is decreasing. So a curve look like this becomes more steep than increasing velocity. If you have a curve is more flat, then you have a decreasing velocity. Okay. So this is on that. And after this, what we are going to learn is acceleration, okay? What is acceleration? So velocity, we have it here. It's delta x over delta t. It's the change of displacement over change in time. Then we will have acceleration here. Average acceleration is the change of velocity over change in time. So acceleration, by definition, is the measurement of how fast velocity changes. Okay, how fast the velocity changes. So here we also have instantaneous acceleration, or we just call acceleration. It's the A for a given instant, for a single moment. So acceleration will be equal to the first derivative of your velocity, because you can write it as this. Its limit of delta t goes to 0. delta V over delta T, okay? So the limit of delta V over delta T as delta T goes to 0. So this will give you the acceleration at a given moment. And then dv over dt, you are going to get your acceleration. And then you are going to see this acceleration is double derivative of your t. And what is the unit here? It's, see, V is meters per second. Over another second, you are going to get meters per second squared. So that's why here, unit of acceleration is distance over time squared. So meters per second squared. And then acceleration is also a vector quantity. And the positive sign means the positive coordinate direction, negative sign means the opposite. So acceleration also have direction because your V have direction, then acceleration have direction. Remember time by convention do not have direction, okay? You cannot travel back in time, so you can only travel forward in time. Okay. So if the sign, see here, we have more things about acceleration. If the signs of the velocity and acceleration of the particle are, this is r, okay, are the same, the speed of the particle increases. If the signs are opposite, the speed decreases. So it's the speed, it's the absolute value of your velocity, okay? So this is acceleration. You are going to see more, like understand more of this when you are actually doing a calculation. So if your acceleration and your velocity are along the same direction, then the speed increases. If they are along the opposite direction, if this is your V, this is your A, then your speed decreases, the absolute value of your velocity decreases. Okay. So we can do an example here. If a car with velocity v equals to negative 25 meters per second is braked to a stop in 5 seconds. Oh, we want to calculate A. I want you to calculate A. How to do? Then A is 5. You need to know how to calculate that. It's your acceleration will be equal to your final velocity, brake to a stop. So it's 0 minus initial velocity. Let me write it the right way. It's final velocity minus initial velocity divided by our travel time. And then it's negative 0 minus negative 25 divided by travel time, which is 5 seconds. So you are going to get 25 over 5, which is 5 meters per second square. So this is our acceleration. So say here, our acceleration is positive, but you take a look at the absolute value of your velocity. Absolute value of this is 25, but then it goes to 0. So speed actually, so absolute value of velocity is speed. So speed actually goes from 25 to 0. So that's why your acceleration is positive, but your speed go from 25 to 0 is decreasing. So this is that. And we also have the checkpoint here. This is a worm, okay? A worm moves along x-axis. So what is the sign of its acceleration if it is moving? So be very careful. The problem asks you to calculate the sign of acceleration, okay? So A, the worm moves in the positive direction with increasing speed. So here, this is, and also speed is increasing. Okay, move in the positive direction, speed is increasing. Positive direction means your delta V is also increasing. So that's why they are both positive. So that's why your A will be equal to delta V over delta T, which is also positive, okay? And then in the positive direction with decreasing speed means what? Positive direction but with decreasing speed. Think about that. I have the answer here, but I want you to think about your delta V first, because this is our explanation here. If you have decreasing speed, then your delta V will be negative, right? Because decreasing speed, your final speed is smaller than your initial speed, so this is negative, okay? And then C is in the negative direction with increasing speed. This is a little bit tricky. So basically, we can use an example. Basically, this is going from -3 meters per second to -5 meters per second, right? Maybe in time t of 1 second. This is an example of going in the negative direction with increasing speed, because the speed increases from 3 to 5. But when you do your calculation of your acceleration, you have to add the negative sign for your velocity. So we should do -5. This is your final, and this is your initial. -5 minus -3 divided by time 1 second, and you should get -2 meters per second square, right? So negative direction with increasing speed, actually you have negative acceleration, and the negative direction with decreasing speed, then with decreasing speed, you are going to use a different case. Is going from decreasing speed, you can go from -3 to -1, right? And then you can do your calculation. It's -1 minus -3 divided by 1 second. You are going to get a positive 2 meters per second square. So negative direction with decreasing speed, you are going to get a positive. So be very careful of the directions. The direction changes, your sign changes, and the direction of velocity changes, okay? So be very careful with that. And we also have the acceleration graph. This is a very interesting graph. So this is the velocity as a function of time graph, and you have to take first the derivative of your velocity to get your acceleration. So here, graph A shows the velocity. The graphs, both of the graphs, they shows the velocity and acceleration of an elevator cab over time. Okay, so this is velocity, and this is acceleration. So velocity is the acceleration. Velocity's first derivative is acceleration. So you take derivative here, horizontal line, you are going to get 0. And then this guy here, you are going to get a horizontal line, and this guy here, horizontal line, you are going to get 0. And this guy here, you are going to get a negative acceleration. And this guy here, you are going to get 0 as well. So taking derivative, you are going to have a positive slope here, and then you have acceleration that is positive. You have a negative slope here, you are going to get acceleration that is negative. Okay, so be very careful. So A, B, go from A to B, you have upward velocity. Going from C to D, you have downward velocity. C to D, you also have upward velocity, but it decreases. So we have negative acceleration. So this is acceleration I will not ask you to do the graphs in your exam, but it's very important. We are going to have a lab that need to work on this, but we don't have graphs in our exam. But you need to understand how to calculate your derivatives and how to use position to calculate the velocity and the acceleration. And also, this is another important part of the chapter is constant acceleration, because most of the motion we are talking about have constant acceleration. We are not going to talk about those motions with variable with acceleration that varies with time. If we have constant acceleration, then we are going to get the graphs of positions. You are going to see a curve that looks like this, but our velocity is a straight line and our acceleration is constant. So acceleration is a horizontal line. You do first integration, you are going to get a straight line. You do a second integration, you are going to get a curve, okay? So if you have constant acceleration, we are going to have 5 special equations, which we call kinematic equation, that can be used to describe the motion. So you can use the equations to calculate your acceleration, velocity, and also position. So here, we are not going to see the derivation of these equations because it takes a long time, but we are going to see how the equations looks like, and we are going to see how we apply this equation. I think some of you may already know the kinematic equation. So these are the 5 kinematic equations that we are going to use, and we are going to learn how to apply it in the examples. So this guy here, this V, so I'm going to write here. The 5 equations gives you the relation between V. Sometimes we write it as V final. This is your final velocity, okay? And A, of course, is your acceleration. And your T is your time. And of course, you have this V initial. This V initial is your initial velocity. And then you have x minus x initial. That will be your displacement. Okay, so these 5 kinematic variables, so these are what we call kinematic variable, are very important to describe a motion move along a straight line with constant acceleration. And we have these 1, 2, 3, 4, 5. We have these 5 equations, okay? Usually, you only need to know how to use the first 3 because the last 2 can be derived from the first 3. So if you know initial velocity, acceleration, and time, how to calculate final velocity, and if you do not have your final velocity, how to calculate one of the variable, time, velocity, or acceleration, and if you don't have time, how to do the calculation, if you don't have acceleration, how to do the calculation, if you don't have initial velocity, how to do the calculation, okay? On your exam, I think I gave you the equation sheet, like all the equations that you will need to use for the exam, but when you do your homework, you may turn into this page and then you can see how you apply them. So these 5 kinematic equations are very important, okay? It's giving giving 4 of the variable here to calculate the unknown one, or giving 3 of the unknown variable, giving 3 of the known variable, calculate the unknown variable. Okay, so you can know, so these are, you can know 3 of them and you can calculate 1 unknown variable. So this one gives you the relation between final velocity, initial velocity, and this gives you position, so displacement, velocity, and time. And this one here, do not have time, gives you the relation between velocity, acceleration, and displacement. Okay, so these are the four equations that will be used to calculate the examples. We also have, so this one here, it's the following. So also, there's one thing I want to remind you, it's A is constant in order to apply the five equations, okay? If A is not a constant, then you cannot apply the equations. So in future, you are going to learn about, there's a name for that. You are going to learn about free fall motion, and free fall, you can use this equation, and also you can learn like if you drive a car, you hit the engine and acceleration is constant, how to calculate how far the car drive. You can also, there are all different kinds of motions that you can use this equation to calculate the different kinematic variable. So remember, A has to be constant. So check point 4. The following equations gives the position x t of a particle in four situations. So these four situations. To which of these situations do equations of 2/1 apply? Okay, so this table, if you want to apply the kinematic equation here, which of the situation that you can apply the kinematic equation? If you want to check that, you are going to, so what you are checking here is actually check if your A equals to a constant, okay? Only acceleration is constant, you can apply the equations here. So which cases acceleration is constant? Remember what is your acceleration? Acceleration is the double derivative of your position. So what is acceleration in first case, second case, third case, and fourth case? Try to do this calculation here, okay? I'm going to erase my pen. So try to see what is your acceleration. The first one is very simple. You take first derivative, you get a 3, and you take a second derivative, you get a 0. Okay? Okay. You wanna try the second one, the third one. The fourth one, double derivative, you are going to get 5. Okay. First one you get a 5t, and second one you get a 5. I want you to try 2 and 3, because 2 and 3 are the situations that you cannot apply the equation because your acceleration is changing with time. Try this by yourself, okay? Yeah, this is an online class. If it's an in-person class, then like you can have more time to do it. But I'll give you some time to try this. So remember, it's double derivative. Okay. So you get the first derivative. You have to do it step by step. Oh, I have an answer. Let's see. Negative 30. Yeah, very good. Plus 8. Very good. And then negative. Very good. Very good. Okay. Thank you. So the second one here, you should get negative. So you are going to get first derivative, you are going to get negative 15t squared plus 8t. And take another derivative, we are going to get negative 30t plus 8. Very good. Okay. And then you have this guy. This guy here is 2 do it like this, 2t to the power of negative 2 minus 4t to the power of negative 1. The first derivative, you are going to get negative 4t negative 3. And then this guy here, you are going to get positive 4 t to the power of negative 2 and take another derivative, you are going to get negative negative become positive 12t to the power of negative 4 and then minus 8t to the power of negative 3. Okay. Wow, you guys are so good. Okay, so very, very good. Yeah. Wow, you guys did a very good calculus class, I think. It's very good. You guys can do derivative very fast. So I'm very confident you can do the homework and you will ace in them. So here, this is what we have, okay? So this is get acceleration, and which situation we have acceleration is constant. When your acceleration is 0, it's also acceleration constant. When your acceleration is 5, it's acceleration constant. But when your acceleration is a function of time, then it's not a constant. Okay, so these two situations you cannot apply the previous equations. And now here we have a very common motion that is acceleration is constant. So here we have free fall acceleration, and here we have, so for every object near a surface, there is a force applied on the object. It's the gravitational force, and it's because of the pull of the Earth. And the gravitational force will give you an acceleration, which is called gravitational acceleration. So here, if we neglect the effect of air on its motion, so if we have this apple here, the particle has a constant downward acceleration with a magnitude g equals to 9.8 meters per second squared. So g we call gravitational acceleration, but the direction of the acceleration depends on how you define what is positive. So if you define going up is positive, then your acceleration will be equal to negative g, which is negative 9.8 meters per second squared. But if you define going down as positive, which usually we do not do that, then your acceleration will be 9.8. So it's a downward, remember, it's a downward acceleration. So every object near a surface will experience the same acceleration, which equals to 9.8 meters per second squared, and it's going down, okay? And we can apply the equations here because your A equals to negative G. Apply this for A equals to negative G is a constant, and we can apply these four equations to any of our calculations. So we have, yeah, we have the definition here. The value of negative G is what we should apply in the equation. Remember, G is a constant, but A equals to negative G, okay? Because we define going up as positive. So we also have, let me see. Yeah. We also have this checkpoint here. If you toss a ball straight up what is the sign of the ball's displacement for ascent and from the release point to the highest point? So you are going from here, release point to the highest point here, okay? And what is it for the descent? So descent means going down from the highest point back to its release point. And what is the ball's acceleration at the highest point? So if you are going up, if we define positive as our going up direction, then our displacement from release point to here should be positive. And so this is our initial, this is final. But if we are going down, this is our displacement. So here, this delta y will be negative. So the sign is negative when the ball moves downward. But the acceleration, what happens to our acceleration? Acceleration will not change with position. Acceleration is a constant. Remember that acceleration is constant. So the ball's acceleration is always negative 9.8 meters per second square at all points along its trajectory. So it will not change with position. It's a constant throughout the motion. Okay, so make sure you understand that. And we also have here, if you did calculus, the area under the curve, it's so area under the A curve gives the change in velocity, and the area under the V curve gives the change in position. This part is not on your exam, so we don't have to spend too much time on it. So it's a graph, integration of the graph. Area under AT curve is the change in velocity. Area under VT curve is the change in position. Okay, and here you can, if you want to do a graph, the fundamental theorem of calculus is change in velocity if you do integration of acceleration. Okay, and then change in position is you do integration for your velocity. Okay, these two is not on. Yeah, we can take a look at that, but 2.6 is not on exam. So let's just go over the concept. Okay, so area under AT curve is change in velocity. The mathematical expression is this, and under VT curve is your position, and the mathematical expression is this. And of course, we have different curve, like you have a weird curve that looks like this. Okay, so if you have a weird curve look like this, if you want to calculate, the change of velocity during this amount of time, you have to calculate this area. Okay, so you can take a look at this. This is this part. So area A under the curve is 0. Area B is this triangle. So you can calculate the triangle is the change of velocity here from 40 millisecond to 8. This is actually 100 millisecond. And then this little area here is the change from 100 millisecond to 120 millisecond. So just calculate the area of the rectangle. Okay. So the total area go from here to the 120 millisecond is this. Oh, actually not 120 to 100. To 110, yeah, from here to here. This area of this rectangle plus the area of this triangle, you are going to get the change in velocity. Okay, so this is that. We have a summary, which is what we went over for this class, especially these equations. So we didn't do any examples of the application of these equations, but on your homework, I want to show you homework. So you are going to do this homework today after class, okay? And problem 5, this is 4t squared plus t to the power of cube, okay? So you are going to calculate the position, and you are going to calculate the displacement, and you are going to calculate the average velocity, and you are going to graph it, okay? Graph it. And you are going to calculate the average velocity. So try to use this guy here, find the displacement, and use displacement to calculate your average velocity, okay? You don't have to draw the graph to calculate your average velocity. So read the problem, and then you should be able to do it, okay? And also for problem like this, you can also calculate your velocity and acceleration at a given time, okay? So first the derivative, we will get velocity. Second derivative, we are going to get acceleration. So try problem 5 today after class. And also for number 2, it's you are driving and there are different time intervals, and you are going to try what would be the least speed you are going to need for the rest of the trip, arrive in time for the interview. So for this problem, you have to convert the kilometers to meters per second, and also kilometers per hour, you are going to convert to meters per second. And also 11:15 to 8, you are going to get time in seconds, okay? So try to use that, and you are going to get the speed in meters per second. And this one here, this one you are going to, this is a very easy one. You have initial velocity, final velocity, and the length. So what do you have? You have v initial, you have v final, and you have length. You are going to use, so you are going to find you are going to use one of the equation in table 2.1 to do this, okay? So this is that. And so yeah, this is also use one of the equation for that. You do not have to do part B. 30, you just need to do part A, okay? So you don't have to draw the graph. So 30A. And then 32. 32 is also using one of the kinematic equations. See here, you have the speed here and brought to a stop. So your initial is given to your final will be 0 meters per second, and you have the time, and you are going to get acceleration. Okay, so this is the homework. Try to finish your homework today so I can give you feedback for tomorrow. And here I'm going to. Here we have lab tomorrow at 11 a.m. So make sure you come to Caputo 227 for labs. And if lab schedule changes, I will email you guys. But for tomorrow, since it's our first time meet for labs, make sure you come to the lab in time at Caputo 227. Okay, so this class takes a little bit longer than an hour, and I'm going to stop here, and I'll see you guys tomorrow. Okay, bye-bye.